All right, so this is section 8-2. Thankfully, it is the same information we've done with our other functions. We're going to use the same translation information as we have for quadratics, as we have for cubics. The only difference is we're looking at a reciprocal function. What we're calling the reciprocal function today is the 1 over x. So let's go ahead and get our highlighters out. And we definitely want to highlight that the reciprocal function f of x is equal to 1 over x. And x cannot equal 0. Because if it's equal to 0, then our denominator is 0, and that is the end of the world as we know it. Our essential understanding information is the transformations of the parent reciprocal function include stretches, compressions, reflections, horizontal and vertical translation. So all the stuff that we have done to functions, we're going to do to our reciprocal function 1 over x. All right, so let's go ahead and highlight our, so we have our parent function, and then we have the function that represents our translation. So if y equals a over x minus h plus k, x cannot equal h because that will make our denominator 0, and that is not allowed. Inverse variation functions y equal a over x are stretches, shrinks, and reflections of the parent reciprocal function depending upon a. So I want you to highlight a. Highlight stretch, shrink, reflect. Because the a value in your function tells you if you're stretching, if you're shrinking, or if you're reflecting. This is the graph of the parent function. Notice that y equals 0. Sorry, x equals 0 is our vertical asymptote. Why can't x equal 0? Since we can't have 0 in the denominator, that makes this line right here, x equals 0, our vertical asymptote. You look, your line, it gets really close to it, but doesn't quite touch it. Also, since x can't equal 0, there is no way y is going to be 0 either. Because no matter what number I put in for x, I'm never going to start this to 0. Because it's 1 over x. So y equals 0 and x equals 0. Y equals 0 is the horizontal asymptote. And x equals 0 is the vertical asymptote. All right, so the question that they're going to pose to us using this information is, what is the graph of y equals 12 over x? Identify the x and y intercepts and the asymptotes of the graph. Also state the domain and the range of the function. So what I'm going to do is I'm going to make a little table to help me graph it correctly. So y is equal to 12 over x. I'm going to give increments, let's go negative, like things that are 12 divides by, we can go negative 6, negative 4, negative 3, 0, 2, 3, 4, and 6. Okay, so we're going to quick make a table. I know when you go to make a table, it may seem like a lot of work, but technically it only takes like 10 seconds. So 12 divided by -6 is -2. 12 divided by -4 is -3. 12 divided by -3 is -4. 12 divided by -2 is -6. 12 divided by 0 is undefined because that is on our asymptote. 12 divided by 2 is 6. 12 divided by 3 is 4. 12 divided by 4 is 3, and 12 divided by 6 is 2. So I have a real quick table. Well, now we're going to real quick draw a graph. So I need -6 on my x, and I need +6 on my x. And I need 6 and -6 on my y. 3, 4, 5, 6, -6. Okay, so I'm just going to plot these points. -6, -2. Oh. -4, -3. -3, -4. -2, -6. Zero, undefined, so this right here is an asymptote. So undefined at x equals 0. 2, 6. 3, 4. 4, 3. 6, 2. So this is going to look like, because my asymptote is x equals 0, funny thing is my y equals 0 is also an asymptote. So it's going to come up, swoop down, and also have a branch down here in quadrant 3. What is the graph of y equals 12 over x? Check. Identify the x and the y intercepts. Where does my graph have x equals 0 and y equals 0? So my x intercept and my y intercept. If we look at this graph, where does this graph cross the x-axis? Where does this graph cross the y-axis? There is no place where this function equals 0. So my y-intercept and my x-intercept, I have none. No x, no y-intercept. I have the same asymptotes as I do for the parent function. So y equals 0 is my horizontal asymptote. And x equals 0 is my vertical asymptote. And I'm abbreviating. Also, state the domain and range of the function. Well, I'm looking at my graph. The restriction on our domain I can plug any x value, because domain is our x values. I can plug any x value into this function except what? What is a no-no for this function in x?
0.
0. So we say our domain is all real numbers except x equals 0. And y values, so if I can plug in all real numbers for x, I can get out all real numbers for y. So my range, or my y values, is all real numbers. And because of the nature of our equation, 12 over x, since I can't plug 0 in for x, I can't get out 0 for y. There's just no possible way, no matter what number I plug in for x, I'm not going to get out 0 for y. So my range is all round numbers except y equals 0. And all three of those things, kind of like an essential question issue, all three of these things tie into I can't equal 0 for x. That means x equals 0 is a vertical asymptote. I can't equal 0 for x. Y equals 0 is my horizontal asymptote. All those three things are tied in. So like an essential question asking how are domain, range, and asymptote related? This is a good example. Okay. Each part of the graph of a reciprocal function is a branch. The branches of the parent function y equals 1 over x are in quadrants 1 and 3. Stretches and compressions of the parent function remain in the same quadrant. So if I'm stretching or compressing, I'm still going to be in quadrant 1 and 3. And just to remind you, quadrants go like this. I, and IB. So 1, 2, 3, and 4. So if you're going to stretch or compress, your branches are still going to stay in 1 and 3. So our parent function is in 1 and 3. If A is positive, we're going to stay in 1 and 3. If A is negative and we have a reflection, it's going to pop it over to 2 and 4. So we're going to look at each of these graphs. So let's go ahead and put these all on the same graph. So let's make So we're going to graph three graphs. So we got y equals 1/2 over x, y equals 2 over x, and y equals negative 1/2 over x. Dividing by a fraction is the same as multiplying by the reciprocal. So this guy is really equal to 1/2 times 1 over x, or 1 over 2x. This guy is just equal to 2x. This guy is equal to negative 1/2 times 1 over x, or negative 1 over 2x. All right. So if you see an equation and the a value is down below with the x, know that you have a compression. So a is with the x, you have a compression. So we're going to have a compression of 1/2. That's why we originally wrote it as 1/2 over x, so that you can see that before we do our number manipulation and make it look decent, our compression is 1/2. So all of our values that we had before with 1 over x are going to be cut in half. So if I had So normally if I plug in my parent function, if I plugged in 1, I would have 1 divided by 1, which is 1. So if I plug in x equals 1, in my parent function, I would get 1. But in this function here, I need to cut that in half. So instead of being over 1 up 1, I'm over 1 up 1/2. In my parent function, I normally, when I plug in 2, I would be, y would equal 1 over 2 or 1/2. So, but in this case, I'm cutting that in half. Half of a half is a fourth. So I'm going to be over 2 up 1/4. Here's something that's going to blow your mind. In my parent function, if I plug in 1/2, dividing by a fraction is the same as multiplying by the reciprocal. That's 1 times 2 over 1. 1 times 2 over 1 is equal to 2. So normally in my parent function, I'd plug in 1/2 and I'd get out 2. So I'm going over 1/2 and up 2. But it's not. In this case, I am cutting it in half. So I'm over 1/2 up 1. Which quadrant am I rolling in for A? Still in quadrant 1. When I have a stretch or compress, so that's a positive A value, I stay in quadrant 1 and quadrant 3. So let's draw its matching buddy in quadrant 3. So that's this one right here. We're drawing all right, so let's see what happens to our parent function. I'm going to do this one in red. When A is equal to 2. So I'm going to double all my outputs. So I put in 1, I should, in my parent function, I should get out 1. But I'm going to double that, so I'm going to get out 2. So it's going to be over 1 up 2. I'm going to put in 2 into the function and get 1/2 into my parent. But this guy is going to double that. 2 times 1/2 is 1. I'm going to put 2 into my function, or 3. Hold on. I put that on the wrong coordinate. I get out 2. Put that one up. Okay. Okay. So we have a little bit of a stretch here, and since I have a positive A value, we're going to stay in quadrant 1 and 3. So sketch his matching guy in quadrant 3. Let's take a look at if my A is -1/2. Now, I'm hoping that we get a reflection, and it's going to be quadrant 2 and 4. So if I plug in 1, so I'm going to skip my parent function now. I'm just going to look at this function here, -1 over 2 times x. If x is equal to 1, so that's this value here. -1 over 2 times 1 is -1/2. So at 1, I am at -1/2. Right here. At 2, I'm at -1 over 4. At 3, I'm at -1 over 6. Closer and closer. So what happens is I have that reflection. When my A is negative, I get reflected across the y equals 0 for the x-axis. So it took this blue guy here and reflected it across the x-axis. So I'm going to take my blue guy here, and I'm going to reflect him across the x-axis as well. So what that does is it loops this guy up like that. So my red is B, my blue line is A, and my green line is C. All right, so that was stretching and compressing. Anytime you change the A value, you're going to be either stretching, shrinking, or reflecting. Now we're going to look at the translations. When we move it horizontally, we subtract that horizontal value from x. When we move it vertically, we add that value to our whole function. And then the A stretches or shrinks or reflects our function. Okay, so we have a graph y equals 1 over x minus 4 plus 6. We're going to identify the domain and range. There's one part here that I do want you to highlight. So it's going to be in pink. The horizontal asymptote. We're going to do all this. Vertical asymptote, x equals h. Horizontal asymptote, y equals k. We're going to need that information later on in this section. It kind of sneak attacks you here. It's not highlighted, it's kind of in the middle of stuff, and it's really, really mega important. So if I have an h and k in my function, my vertical asymptote is going to be x equals h, and my horizontal asymptote is going to be y equals k. So the best way to graph a function is to lay down your asymptotes with some dashed lines. So let's put my x and y axis on here. Let's figure out A, H, and K. Thankfully, comparing it to this function here, A is 1, so there's no stretch, compress, or reflection. H is 4, and K is 6. So my vertical asymptote is at x equals 4. And my horizontal asymptote is at y equals 6. So I'm going to throw those down on my graph. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So my x equals 4 is this line right here. And y equals 6 is this line. Right here. If I had to do this over, I would move my whole graph down. But as it stands now, I'm just going to do it all over the top of everything. Okay, so instead of my horizontal asymptote being at the origin and my vertical asymptote being at the origin, it is moved over 4 and up 6. So my new graph, I have no reflection because A is just equal to 1. So my new graph looks like quadrant 1, quadrant 3. Once you have the asymptotes down, you're good to go ahead and draw the reciprocal function. If you know the asymptotes of the graph of a reciprocal function and the value of A, you can write the equation of the function. So now we're going to work our way backwards. We're going to take the graph and write the equation. This graph of a function is a translation of the graph y equals 2 over x. So we're starting out with y equals 2 over x. We know A is equal to 2. Thankfully, they give that to us. We don't have to figure that out. What is the equation for the function? So we know that our horizontal asymptote, so we're counting here by 2's. So 2, 4, 6, 8. And it's the same on, okay. I write that down. Sometimes they give you wonky graphs in the book, and if I were to draw this graph, I'd do it with a scale of 1, but they have a scale of 2. All right, so we're looking at this. This asymptote right here is x equals 1. This asymptote right here is at y equals -2. So from that information we highlighted here, we know that our vertical asymptote is at x equals h. So we already know the h of our function just by looking at the graph. And the vertical asymptote is at x equals h, and the horizontal is at y equals k. So x equals h. So we know that this is h and this is k. So we can take our function and plug in our values. They give us this part here. They give us that a is 2. And k is equal to 2. So when it asks us what the equation is, we look at the asymptotes, we find h and k, and we plug those into our equation. And that concludes it for today. Go ahead and write your summary. Summarize what the section is about, and you will be finished.